Okay, I want to help. I want to start a relay. Should I to start an exit relay in my home, or what do you need? What can I do with my hardware for you?
I think exit relay at home is not a really good idea, because your ISP might contact you about abuse, and it might block your home network and the things from your family as well. So I think if you want to start, having just a normal relay and not an exit relay might be a good learning experience. And then, starting from that one on.
So we also have the concept of bridges, which are basically relays which are not public. You could see it as like, a hidden relay, which are used for censored users. And for a relay, we want it to be online very constantly. It shouldn't, go up and down, because it's not very good for the network. So if you have a little bit of a flaky connection, it might be easier to just start a bridge. And I think you can actually do that in Tor Browser, right? Or you could do that? No?
Not easily.
Not easily, okay. But still, it might be the best option,
yeah,
right?
That's true.
Yeah.
Okay, so for entry level, do go with a bridge. If you're a bit more a better connection at home and you want to commit to this long term, then go for a relay. And what are the requirements for actually becoming an exit node? What would it require? Are we talking about hosting and a dedicated?
Right. So I would say you should have a plan for what happens if you get abuse complaints, right? So for example, we were starting to start one at my university in Karlstad, and we already have a lawyer who would take care of that for us. Or if you do it at a data center, your ISP might be able to do that for you, and maybe they drop you an angry email if they have to do it for you. But the important thing is you shouldn't be, on your own if that happens, and if things go badly. So it also depends on how much do you exit, right? Because we have different policies. Nobody exits port 25 for SMTP because you're basically sending spam, right? So that is being ruled out. So we have different exit policies, and if you reduce it a lot, you actually don't get a lot of abuse complaints.
Yes, one question about the hardware. How fast, what kind of line do you normally want to have before committing to using ordinary relay? And what kind of hardware in specific? Could you use a Raspberry Pi, for instance, for new models?
I don't know.
Right, so we have basically a minimum threshold, which is kind of low, like a couple hundred kilobytes. Below that, your relay is practically useless. And apart from that, the more the better. So, if you have 100 megabit, that would be pretty cool. If it's less than that, might still be useful. And the thing is, the more you relay, the more CPU you're gonna need. So a Raspberry might not make you very happy, and probably also not the Raspberry. So the more dedicated power you have, the better. And we have some really fast relays which have to go to great lengths to keep that up. For example, modern Intel CPUs have some speed up for the AES operations, which would help you in order to relay more traffic. So yeah, the more the better. At least I would say a couple hundred kilobytes would be really useful to the network. But yeah, a Raspberry might be a little bit too slow for that.
I'd like to ask you about the consensus. You said that you need at least 50% in order to lead to something, but on the example you gave, you were only giving three nodes with the flag enable, which is less than that.
Yeah, for bad exit, we only have 3 out of the total of 9. So for most flags, it's 9 which vote, but for bad exit, it's only 3. Because the reason for that is we need to be flexible to some degree, right? And if you have to go to 5 relay operators every time this happens, it's going to get a little bit annoying for everybody involved. So it's a little bit of a trade-off, right? We want to be fast, but at the same time we still want to distribute the trust. And 3 seems quite good, right? Because as long as we can reach 2 relay operators in a reasonable amount of time, we're fine. And that's usually the case. Yeah.
Are those 3 in different jurisdictions?
They are
actually.
Yeah, the one is in Austria, one is in Germany, one is in the United States. Yeah.
So I read, I'm not sure if I remember this correctly, but the Tor network does not try to protect against an attacker who has some kind of hypothesis about the identity of some user, like the attacker monitors what goes into your entry relay and what comes out of the exit relay, and then through timing and size and stuff could sort of easily confirm his idea that you are this particular user. Is this true? And if so, is the intention to keep this assumption that these attackers are not considered, or is the plan to do something against that?
So, should I take it? So the thing is, there are two kinds of anonymity networks you have. You have so-called low latency and high latency anonymity networks. And those low latency anonymity networks like Tor are used for web browsing and interactive messaging and things. And they are not up to these kind of attackers, which can monitor before their first node and after the last node. So this kind of traffic analysis is one of the things that Tor excludes out of this threat model, because in order to cope with this attack, you usually have to have some kind of smart dummy traffic thing where we send constantly traffic through the network, and your stream is basically hiding in this dummy traffic. And this is quite costly, which is basically not usable if you have a low latency anonymity network, because then your browsing, your instant messaging is not usable anymore because due to all this dummy traffic. So there are plans to work on this issue. There's one PhD student who's writing his dissertation on how we can maybe have a smart dummy traffic strategy up to the middle node in a way that we still be able to serve the web anonymously and at least thwart some forms of this traffic analysis. But it's a huge open research topic currently, and some people are even debating that this kind of de-anonymization is really working in practice. I mean, the math is clear that it's generally possible to make this kind of correlation, but maybe the load and the noise on the Tor network is so huge currently that it's giving you just a huge false positive rate and makes this kind of attack useless. But it's sort of speculation, and it's an open research topic. Currently, we say we are not safe against such kind of an attacker with such huge resources.
Well, there is an example of a confirmation attack that I don't think Tor can do anything to actually hide against, which is what happened to Jeremy Hammond to make him, when they confirmed that Jeremy Hammond was actually who he was. So they identified him, they had a suspicion, they looked at IRC where he was logged in, they found his house, they cut the power to the house, and he dropped off IRC. So in a low latency network you will never be able to protect against that kind of confirmation.
That's true.
So I'm curious about DPI and censorship. So the current state of the art would be OBS4, which is based on Philipp's scramble suit. And my question is, what do you foresee any attacks by probably the Chinese to crack OBS4? Obviously it can't be cracked in the same way that you can dynamically detect OBS2 servers, but what can you do against OBS4?
Right, so I wouldn't say probably the Chinese, because I think Procera is based in Sweden, right? Or it used to be based, so you can never know where it's coming from. But yeah, it's hard to say because usually what happens is things you do not anticipate. So we had a lot of smart designs which worked in Iran, for example, and then what they did at some point was the very simple thing of just cutting TCP connections or terminating them after 60 seconds. And nobody saw that coming. So, you know, you tunnel your traffic happily, you surf the web, and after 60 seconds it was over. And yeah, it's just an example of the general idea of, you know, they tend to not do what we think they will do, because, you know, what we think they will do is the hard thing to do, and what you're facing is not some you know, powerful adversary with highly, you know, extremely smart people. What you have is people who just try to get their job done as easily as possible and to please their boss, basically. And I think they're actually doing a good job at that, because many of the attacks we're seeing are, you know, surprising, but they work pretty well actually. So yeah, I don't think I can give any smart predictions about that. I think we're doing kind of good now, especially with things like Meek. So for those of you who don't know, it's a really cool system where you can tunnel traffic over cloud infrastructure, like Google, for example, because it makes use of the way basically content delivery networks work. So this is something which is used in Tor and in many other circumvention systems too, like Lantern and Psiphon. And it looks pretty promising, and maybe it's going to be broken at some point, but it will probably be broken in a way we couldn't really anticipate. So yeah, I'm sorry that I don't have a better answer to this.
But and they can always if there are high holidays or things, they can just put all those traffic in the trash and interrupt it because they can't decipher it. It's always the option they have, like disrupting things and making it really annoying for users. And then you can have the best scheme in the world, but it's still not usable because users are saying, well, I can't use it, I can only use it half a minute a day or what, and go away with it. So it's hard problem. Mm-hmm.
You were speaking about end-to-end encryption on Dotonian sites. How end-to-end it is?
Hidden services?
Yeah, for example, if you use SSL, you know that the end-to-end encryption goes from the browser, whatever you're using to connect, to most likely the web server, unless they are using one of these SSL aggregator systems. So how it is for them?
Well, end-to-end basically means Tor to Tor, which could be end-to-end, but not necessarily, right? Because Tor is a SOX proxy, and SOX is a network protocol. So if you're, having Tor on one machine and you're connecting to it over SOX from a different machine, then there is a small gap between the end-to-end encryption. But as long as you have both on the same computer, it doesn't really traverse the network in clear text. Does that make sense?
I think this is one of the things Facebook is concerned about, because the traffic is terminating on their Tor hidden service box, and then it has to be rerouted into their internal infrastructure to get other things loaded. So there is maybe a small gap, yes, that's true. But at least you can be sure that you're reaching Facebook in an unmodified way.
Yeah, so the reason for that is what we call self-authenticated names, right? Because if you look at hidden service names, they're a little bit hard to remember. It's not as easy as facebook.com. It's basically a lot of long, difficult to remember digits and stuff. And the reason for that is what you're seeing is not what somebody chose. It's just the hash of a public key, right? Which means that it can authenticate itself, which is really cool, but it comes at the cost of, it's hard to remember it, right? And it's funny because Facebook did a good job at still designing it in a way that you can kind of remember it, which was basically luck for them. They just tried to compute many, many public keys, and then by what was really a lot of luck, I think they got one which sounds like an actual domain name, and everybody thought, oh my god, they just broke hidden services. They should never have a name like that. But no, they were just really, really lucky. So.
Mm-hmm.
You're mentioning that you can detect if the exit node is doing something with traffic. But I was wondering, how can you detect if it's just sniffing the traffic and
Ah,
not
yeah.
doing anything?
That's a good question. So if somebody is only sniffing and doing nothing else, then you can't. But what people usually do is they go a little bit further, right? So what I did a couple of days ago is I fetched a web page and over every single exit relay I passed a unique identifier. And then a couple minutes later, so I did that for every single exit relay, and what you would expect in your logs is to see every request only once from the exit relay. And for one exit relay I saw it twice. From a relay in Japan. And that was funny because it was first the exit relay and then it was another IP address, also from Japan, which was not a relay. So it looked like somebody who was running this relay in Japan basically just tried to fetch the same site again, which was called passwords.txt, because I wanted to encourage people to actually fetch it. So this is one way how you can catch something like that.
You told us that you were going to, you were aiming on keeping the current sort of user model, that is using the Tor browser as the main source for browsing the nets anonymously. I've been seeing a lot of activity on the internet lately using a different user model, that is creating some sort of device, a router or a dongle. There's been Kickstarter projects, there's been the Portal project from the group, and there's I think Adafruit has some project that you can create an access point through your Raspberry Pi to sort of create a persistent device in your home that you could easily connect to and that you cannot, excuse the word, may fuck up the connection in any way. Have you any thoughts on that user model? Is that a good or bad way to go about things?
Yeah, this is one of the directions we are currently investigating. There are prototypes out there by some of the Tor people who developed Tor routers, and we are trying to find a way to post the experiences we had actually with developing these kind of systems and giving hints to the community how we could further develop in this regard. So this is a hot topic, and there are some Tor folks working on these things. So this is a legitimate user model, having all your traffic routed in a secret way through Tor, be it at your home or anywhere else.
Just one more point. It's also really hard to get right, because we've seen things which got into production, which were being sold, and which turn out to be horribly broken. And one example is SafePlug.
Yeah, SafePlug.
So right, so it's one of those things you plug it in, and then you can just basically use it like a gateway, right? And it transparently tunnels everything over Tor. And we looked into it, and it turns out that an exit relay would be able to, by manipulating the traffic, trigger an update of the SafePlug thing, which is sitting on the client side, and then it could basically break into the HTTPS and inject a binary which then gets executed on the user side. So you could basically on the fly identify and own SafePlug users, and that's basically a good example of how you shouldn't do it.
Was that the Kickstarter project that was pulled?
I think that's a different one.
Okay, because
that's a different one.
It's
a different one. Yeah.
Okay.
But I think the reason it's a cool concept, but we haven't really seen a successful one yet, because it's really hard to do, harder than most people think.
Tor's have been working on that. Tor has actually full support for transparent proxy, at least on Linux systems. You can just enable it with Redirect, both for IP version 4 and IP version 6. I have to write the patches for IP version 6, that's why I know. And the most important thing you should take into account there is that if you are going to redirect traffic, you will not be able to use UDP traffic at all, because Tor has no support for it. So that's a problem you should take into account when designing networks using Tor as transparent proxy. And it's usually when you are more likely to fuck up if you try to do that.
Yeah. Okay, I have another question. So, I've been thinking about how much would it take to de-anonymize a user where you don't have a hypothesis about the user's location. And so if obviously I can't start running 3,000 exit relays in one day, and obviously they can't be in the same on the same subnet because that would be an obvious cluster. But if I distributed them evenly over a bunch of cloud providers and different data centers, probably data centers because I want as much traffic as possible, and then did this over a period of 2 years. Since you have 7,000 relays and only about 1,000 exit relays, wouldn't it, so my previous thought was that you would need to be the NSA because you need a global view of the internet. But what you actually need isn't it only a global view of a good enough view of the Tor network. So if I started 3,000 relays over a period of 2 years, would that break Tor? And if so, how much would it cost?
You want to take that? So I think a part of the answer is what comes down to guard relays. So those are basically the first ones you choose. And right now, if you start a new if you start Tor, it picks, is it 3 for guard relays? I think it's 3.
Yeah, but we are on the way to move to 1 guard.
Exactly. So those are basically a set of 3 computers which you only use as the first hop, right? Only 3 and not any other one. And somebody basically did some simulations and tried to figure out is this even a good idea, right? Because sometimes it's really hard to argue about the security properties, and it looks like it's not a bad idea, but it could be better. So I think there are some proposals to move to only 1 now, to 1 guard, which should make it harder, right? Because you have a lot of relays, but if you don't happen to have this single one you need, then it's harder for you. So I think, I mean, if you have 3,000 relays, you probably, we have a lot of other issues, but it depends on a lot of things, I guess, where in the network you are and how could you maybe trigger the user to, to change the guard or something like that. So unfortunately, the answer is always, it depends on your threat model and stuff. And in that case too, but you're probably pretty successful already if you manage to run 3,000 relays.
And it's usually as well the case that we try to keep track of people. Like, do the servers behave in the same way, or do they have things like the same contact information, for instance? You would spoof this probably, right? So you wouldn't say it's Frederick all the time, because it would give you obviously some bad things, but there are other non-technical means, like trying to get in touch with people who are running huge relays and large clusters of relay, or a bunch of relays. But at the end, if you are really sneaky, that could be hard to detect and have some impact on the Tor network.
Wouldn't it be easier to break it by getting 7,000 computers small next to each one of the existing relays instead of getting 3,000 new ones?
Maybe. I mean, that's a good point, but there are other points to consider. For example, we are only talking about relays here, right? About the first and the last one. But what about the path between the client and the relay, and the exit relay and the destination? I mean, this is a long path in the network, which is going maybe all around the world. And now consider people who have access to BGP routers and who are able to just hijack parts of the internet without people noticing and redirecting parts of it to them. So this is something which for a long time wasn't really considered, that, ISPs, for example, always control your first hop, right? And if you are going basically over your ISP and visit the website of your ISP over Tor, it's not going to help you, right? Because your ISP sees the beginning and the end of your communication. They can do what is called end-to-end traffic correlation. And this is, a difficult thing to consider, right? And good luck trying to teach that to users, because they just know that they're using Tor and they're going to be safe. But that's not universally true, because it depends on a lot of really nasty networking issues we're facing on the internet, just because it's poorly designed in many ways.